I wish I had.
Like, was it?
So, like, the index HTML already has all the demo slides in it.
Yes.
Yeah, just delete it.
You do,
Oh, is
yeah,
that what
you
you
do.
mean by
Okay.
deleting
That's
all of
what
it?
I mean.
Oh yeah, I delete all of it. Except like
It would
one.
be cooler if it was just blank and you could just start working.
Yeah.
Oh yeah.
Open.
You could do a pull request for just like underscore boilerplate.html. That's not really exciting.
Hi everyone. Welcome to our very first retalk. The idea behind the retalk was to give speakers an opportunity to present again, and also to give members that are not able to come in the evenings during the week an opportunity to see some of the talks that they might have missed. So let us know what you think about it later. We are sponsored by DevBootcamp. That's where you guys are right now. They just opened up in February, and they've been great sponsor of us up until now and will continue to be. And we're going to have our BYOPs monthly bring your own project nights here going forward. So Kimbra is the representative of DevBootcamp. She's going to come say some words after I'm all done. And she's very happy to give tours and talk more about the program if you're interested. Here's the Wi-Fi info if you didn't already get it because it's up on the board. So we have a code of conduct at SDJS that governs all of our events. Basically, it's be nice. There's a link right here, and these will be posted later if you want to go check it out. It's also on our website.
Is that superscript to make the hearts go up like that?
No, it's just the emoji is the 2 heart emoji.
Oh.
Yeah. There's a cluster heart emoji, but I never know what to search to find it because it's like 5 hearts, but if you just type hearts or something, it doesn't come up, so I don't know what it is. So this is our team of organizers. Our pictures are a little bit small. Today we have myself, Stuart, and Todd, and Abhishek. Feel free to come and ask us questions if you need any. You'll see them around at our other events as well. Here are some of our upcoming events. You can find them all on our meetup page. So later today, if you're really feeling motivated, you can go up to Scripts library, and there's a JavaScript study group, which Todd will be running. There's a full stack JS meetup at Zito on March 31st, if that's your thing. Zito is an awesome place as well, and they sponsor a lot of our events also. The monthly meetups are at Zito, and the next one is April 5th, and those are primarily lightning talks, so it's a lot of 5-minute talks about all sorts of different things, so it's good for all experience levels and interest levels, and you can come and go whenever you want. And then we're doing an Ember 101 workshop on April 13th. We haven't found a location for our event yet, but we did this last year, so we're going to update the content, and it was awesome. Like, all 50 people that RSVP'd showed up. We're trying to find a larger space to host up to like 100 people if possible. So if you know of a company or a space that we can put 100 people in for a workshop, let me know. All right. We're always looking for speakers. Like I said, we do the lightning talks at our monthly events, which are in the evening. And those are really easy no matter what level you are to give a talk. My brother over there, he's given a lightning talk, and he just graduated from SD Learn Code Academy this past cohort. So, you know, just it's a really easy way to get started giving a talk if you've never given a talk before. There's not a lot of commitment or time you have to put into it to make a good, since it's only 5 minutes. Today's speakers, we have Chris Highstand, who's doing async await use patterns, Brady Weatherington, who's doing Node in production, and I'm really excited because I missed this one. I've seen Chris's before, but I missed Brady's because I was out during. See that one? Lame. Anyway, words from our sponsors. Kimber's going to come and talk about DevBootcamp.
Hi guys, welcome to our space. I think JavaScript meeting when I gave a talk on DevBootcamp. Essentially, we're a 19-week program.
So Stuart has streamlined our working on it, but it's available now, right, for all of our events, for our monthly events. So if for whatever reason, feel free to log in. We're live streaming
Yes, that's the new process. Is now we're actually directly from.
All right. Basically, I started using async await like 5 or 6 months ago, and just kind of noticed some patterns, and thought it'd be useful to show to people who hadn't really used it much. Just help you get bootstrapped. The first thing that you should know about async await is that there can be hidden errors. So in this example, we're doing an HTTP GET, and there's nothing wrong with this function except for that this server is not actually running right now. And so when we call main, it calls this function and tries to store the result into data, and then it's going to say, oh, we got the data. And what happens? A big fat nothing, which really stinks. That's not what you want. You want it to fail with an error message at least. So how do we fix that problem? Well, at the top of files that use async await in the entry point, so not in library functions, but in the entry point, I usually put this, and then it just throws the error. So otherwise this code is the same, and then what happens is this, and you get a useful error message. You could also, in the previous example, if you really wanted to do something like dot catch, that kind of thing, and then that would catch the error too. But this is all about uncaught rejected promises. All right, so this is just how we do async with promises without async await, and this is just a comparison and contrast. So the first thing you do often in functions is you'll create a variable to kind of store your state that you're going to use inside of the promise chain, which is just a little bit awkward to have to create it up here, and then maybe you don't use it until lower down. And then you call this first, and then you'd think maybe this should run second, but no, you're wrong. This is second, and then this is third. And so you just have to know that and structure your code in such a way that you don't get out of order operations. And so then this is what it looks like with async await. This happens first, this happens second, this happens third. You don't have to do any kind of I don't know if it's not hoisting, but you don't have to declare your variable so that it's a more global scope ahead of time. You just declare it where you need it. So this yields readability, cleanliness, easier to maintain code, and so forth. This is just an example of what not to do. In this case, we have a library function that's unnecessarily doing 2 remote calls, and it's just basically be efficient. This is even without async await or promises. This is just a bad programming example. And so then when you run this promise or asynchronous function, you end up getting the config more times than you need to. Instead, it's better to get it once out here in main, and then pass it in to each async call that uses it. And then this is kind of a neat example right here, where we're starting the remote call three different times with 3 different keys, and we're just hanging on. These are kind of like references to that remote call. And then when we want to actually get the values for those remote calls, we can destructure it in this form by using promise.all. And we just pass in the array of the promises. And then it doesn't matter which order they resolve in. The order is going to be maintained. And so you're going to get value 1, value 2, and value 3 corresponding to key 1, key 2, and key 3. So that's a very helpful pattern to use. Something useful that I found while testing is sometimes you, especially when testing, you start doing a decoupled remote operation, and it's not really clear when the operation's going to finish because maybe there's not really a clean hook for it, but it shouldn't take longer than a second or 5 seconds or whatever. Well, now we can do something like sleep in a synchronous language, but we're doing it in an asynchronous language, which is really neat. And all you have to do is import Bluebird and then use promise.delay or bluebird.delay with the amount of milliseconds you want to sleep for. And then this code won't run until a second after this begins sleeping, at least a second. Here's another kind of performance optimization pattern, and you can ignore the kind of setup here. This is kind of the gist of it. So we are we're running this function which returns a promise, and we're storing the promise here in output queue defer. And then we're not using it right away. We're letting that remote operation happen. In the meantime, we're doing some work that takes some time. And then chances are by the time we get to this line here, or the interpreter does, then that remote call will be done already, so we don't actually wait at all on this line right here. So the idea is you just fire off remote calls in kind of a performance optimal fashion, and then you do other things that you have to do while you wait for them to return. It's just a little performance or speed boost, I guess. All right, so in summary, use promises everywhere, or async functions. If you guys are using promises right now but not async await, transitioning to async await is going to be super easy. So I really encourage you guys to use promises if you're not. Yeah, minimize the number of remote calls for a function. Yep, that's it. Here's a blog post that kind of goes into maybe a little bit more detail at times. Thank you very much. Any questions? Sure.
The whole like const. If you as a constant, I guess it wouldn't.
You're saying if you.
Yeah. So if you like await, or if you if you wait a value coming out, and you have
like if you do that.
Yeah.
I'm not sure what would happen. I'm not sure how much const is enforced on the object. It's not.
I've had that.
Right, and that's what I'm wondering is, will it yell at you? Will it say, "Oh, hey, this was referring to the promise, and now it's referring"? But I guess not, because
From the way I read it, the object reference which is also like variables equal.
Good to know. Any other questions?
There we go. Hi, everybody. This is production node. There we go. Okay. So, I'm Brady. I work at a company called Verify. So I was having a discussion with a friend of mine about various programming languages and stuff like that, and this is the metaphor he came up with, and I thought it was like super apt, which is Node is basically exactly like that guy from Fury Road who goes and spits gas into the supercharger at the top of the car to make it go faster. That's kind of what Node is. So do a little bit about just some architecture stuff you guys probably already know, so I'll keep it brief. But the way that Node wants to work is you are it's running in one process. You're setting up a whole bunch of requests where you say, hey, read this thing, write this thing, write this thing, and then when you've read those things or written those things, call these various callbacks. And that's the entire event loop right there. And so what that ends up being is like super duper high performance. So where it starts to be not as good is when you're dealing with high CPU intensive stuff. Node really wants to do I/O. It doesn't want you to sit there and churn on the CPU. It'll really start to fall down if you hit it too heavy on the CPU without doing some sort of clever thing like forking or having worker processes and stuff like that. Also, if you have a big, gigantic, crazy amount of code, it starts to get unmanageable. Also, don't use it just to serve files. That's in some circumstances you can do that, but a regular web server is going to completely destroy it in terms of performance, so there's no point. I also would say that if you're just doing a standard issue MVC app, like what you would normally do with like Rails or Laravel or anything else, I wouldn't bother doing that in Node. You're not going to get enough of a benefit, and those other environments are just a lot more pleasant as a programmer to use. And also, if you hate JavaScript, you're not going to like Node very much.
Something.
Yeah, sure.
Yeah, CPU or memory and
Yeah.
work. Yeah. Like hardly any memory at all, it'll crash.
All right. So, thus, to your point, what will happen is Node will crash on you at some point. So, basically, if you have anything in your code where there's some exception that for some reason you didn't foresee, and a lot of the time it can be buried in some sort of library that you didn't realize that you were using. Like I've had something where I was doing something with, I think it was MySQL or something like that, and then it threw a DNS error at me. Or I was doing something with SQS and I got some other crazy error. When that happens, it can crash, and certainly, especially if you forgot to catch that particular error. And if you're doing, you're not doing what they call Pokemon exception handlers, where you try and just catch everything, then it's going to be hard to go and list out all the possible exceptions that can happen. Because if you do something at high enough concurrency, something that happens one every 100,000 times is going to happen all the time. And so the problem is that if you have, like I said, it's high concurrency. So if you have a ton of connections that are all processing at the same time, one connection has something that goes slightly bad, everything falls down. And this does not happen in like your conventional environment. So like if you're doing something in like let's say PHP and you screw something up, you may get a 500 error page for that one request, but all the other requests that are running on the server are fine. So basically, that same event loop that I was showing before, imagine there's one little request of the thousands that are running right now that has something that goes wrong where you didn't catch the error. Well, now everything is dead. So this is the stuff that we do, basically down from the code level and then working our way out towards the cluster level of advice we have on how to run the stuff in production, dealing with that sort of crashiness and first off, some really nice tricks for testing. If you want to actually see this stuff yourself, make a really simple URL that you can hit, call it something like crash me, make sure it does not run in production, it only runs in development and test mode. And then make that just, force an exception to happen and don't catch it and watch the server go down. And then also make yourself a sort of a long-running URL that it just sits there, sleeps 30 seconds, and then says, hi. And that's it. And run curl a couple of times against Node, hit the crash me URL, watch.
So you can hear it. All right, it's clear, right? Dependency injection is a way to decouple your code. Oftentimes, to do something, you have to depend on other things, a database, a file system, and you don't want those to be very tightly coupled into your program. So dependency injection allows you to pass those dependencies into your function so you can do great things with it. I'll give you another example. So imagine that your kid was your program, and if you didn't have dependency injection, basically you would have to take your refrigerator all the time and just say, go for it. And you can imagine all the chaos that would ensue. So with dependency injection, you still make your program happy, but you can provide it with whatever food you want, wherever you want. So that's another way to think about it, is you control what your program's getting. All right, so why would you use this? It's going to help you reuse components across projects, even within the same project. It's going to let you test easier because you're going to be able to swap out implementations. And even in production, or as you move through environments, you'll be able to swap out the implementation. It also makes your code more readable by taking those out. You can also shield your own code from API changes. So it's kind of an adapter or translator from your dependencies. And sometimes it helps you from having to pass down a whole bunch of stuff throughout your program. So when are you going to use this? You're going to use it when you want to loosely couple your components. You want independent things that are very specialized. Another way to do that kind of thing is through event emitters, as Brady was talking about. But this is an instance where you don't want to use event emitters and you want to actually have a reference in there, but you want those components to be independent. You can also think about this as separating your layers. So you have your database layer, that would have a set of components. You have your domain logic, and you can inject your persistence layer services into your domain logic and keep them loosely coupled. You can also use this to inject configuration. I do this between environments. You can use a configuration file rather than having to go into your code to make any changes. If you're going to use the same dependency with multiple components, again, you want to modularize it and inject it. So there's a few other things, but I think we'll get on to when you don't want to use it. This is when you're never going to have a different implementation. It does what it does, it needs these dependencies, and you don't really need to configure that stuff. You can definitely have a more direct connection to your dependency. So you may be thinking, oh, well, doesn't CommonJS do this for us? Isn't that dependency injection? Not really, because as soon as you change that reference, you've changed the code. And the idea with dependency injection is you don't change your code, but you get a different implementation as you run it. So it's a runtime change rather than a code change. I highly recommend, especially on the server side, Architect.js. It's used by Cloud9. They have Cloud IDE. They use this extensively. I've used Architect for a few years now. It's really cleaned up my code, made it very modular, very easy to work with. You can also use this on the client side, but a lot of the frameworks have their own ideas of dependency injection, so you're getting the benefits without having to roll your own. So, for example, Angular has dependency injection for... All right, so let's look at some code here. Maybe. Down here. All right. So I have a node project, and this is, you can think of it as this Express application, and I have my plugins in this directory. The example that I have on the server side is I want to generate a whole bunch of random names. So I have the logic to actually generate the random names. I have a plugin that does the randomization. I have a plugin that can load that data into the database. I have another plugin that can save it as a CSV. So all of those can be reused with really any project because they're independent. And I essentially merge them together. Yeah, and I can essentially merge them together through Architect and this configuration file. Now, there's a lot of dependency injection libraries out there, and they all have slightly different ways of doing it, but the idea is the same. You have some sort of container, which is a representation of your application. Then you have configuration that tells it, okay, here are all of the services or all of the components, and this is how they're wired together. Okay? So with the plugins, you have a list. Each one of these represents a package, an independent bit. So this is how I do my console logging. It gives me pretty output. This is how I do the randomization, and you can kind of guess by the names what the other stuff does. Down here, you'll see that I'm passing in some options at runtime. So I can, without changing any code, I can change the file name, I can change if it's going to output to a file or save to the database. I can do all that through configuration. So if I want to have a different configuration for my test environment versus my production environment, I can very easily do that through declaring it here rather than having to dig into the code or having a lot of logic within my application that will modify the behavior. So each one of those, like I said, is a package by itself. So let's look at the name generator itself. The name generator, the most interesting thing is this plugin component of the package.json. So we're just piggybacking on already what Node uses to describe a package, and we're saying it's consuming all of these services that I've configured, and it's providing this particular service to whoever wants to use it. And as you might imagine, it doesn't care what the implementation is behind that, so I can switch that out whenever I want as long as the interface is the same. So that's what makes this very nice, is when I'm testing, I can swap this out and I don't actually have to write to the file system if I don't want to. If I find a new NPM library that I want to use, as long as I provide the same interface, it's going to work. All right, let's talk about the implementation of it. In a lot of ways, you can roll your own dependency injection by just writing good functions. So your function should take whatever it needs, so it's a pure function. It's only operating on what you're giving it. It's not depending on state outside of itself. Architect uses that same thing. It's going to pass in the options from the configuration file. It's going to pass in all the services that you've said you need. And then once everything's set up, it's going to register those services for other plugins to use. Then you have your implementation. Whatever implementation you want, I've said here is my service and here's its interface, and I'm going to provide that to the other components in the environment. Okay? So in a lot of ways, when you're writing these plugins, you're only thinking it's doing this one thing, and it has these services. Those services have an interface, and it's just going to operate on that. And you can think very clearly about where my dependencies are. So as an example of one of the benefits, if I look at the test for this, you can ignore the mocking stuff that I'm doing, but I have a service that I want to use. So I'm just instantiating that service as a dependency in the system, and then I'm injecting that. So I don't even have to use Architect to do the testing. I'm simply calling the plugin function. I'm providing it options in the test. I'm providing it an object with all the services, and then I'm creating that service and then testing it down here. So I have full control over what that particular plugin has access to during testing, just like I have full control over what it has access to during runtime, because I can configure that stuff. Okay, same principle goes for my database. It consumes services, it provides a service with an API, and I can test that, or I can construct that interface in the plugin and provide that to the service. Okay? So that was a quick example. I do have an example of how to use it on the client side, but I'm sure I'm over time at this point. So if you're interested, we can talk after. Oh, okay. All right. I'll give you a quick example of what that looks like. I have a simple, actually I have it up over here. I'm using old school AMD just to keep it simple. I have my configuration file that I pass over to the client. That looks very similar to what we saw before. I'm saying here are the packages that I want to pull into my application. I'm going to use Architect to make an application. Then here's an example of what the plugin looks like. Instead, it doesn't have the concept of a package JSON, so I have to tell it what service it's providing. It has the same function signature for the plugin itself. It takes options, it takes a list of services and a register function, and then I'm just returning that plugin. And here's an example. I am providing the same math service, but this one has advanced logic. So in addition to basic math functions, this one handles square root and logs and stuff like that. It's providing the same service, different interface to allow the system to do more advanced things. Okay? And that's it. I'm just going to wrap it up. So you can see all that in the presentation in this repo. And that's it. You're ready to take the red pill. Questions? Yes.
Do you use this in all your projects?
I do. Makes it super clean.
Big file just is like
I typically do that when the configuration is more or less a static object that I just want to encapsulate and say, this is stuff that it needs to just bootstrap.
so like scalars. It's like 500 or 7 value. That probably goes in a config
Yeah,
file.
if it's really not going to change, then you can put it in the package and you can control it like the rest of the source code. Anything that you want operators or other developers to be able to tweak, or you want to be able to tweak at runtime, you would want to pass in through the configuration file. Do I have an example? Not off the top of my head, but what I tend to do is if there's a difference in the production code or environment codes, then I'll use environment variables. Where's my splitter? There it is. So because this is a JS file, I can use an environment variable to pass that in. So you do process env, and you'd say, right? And that way, I'm controlling it through process variables rather than environment variables instead of hard coding it here. And that is usually the recommended way. You can do some conditional logic and have multiple versions of the config file, but that tends to get a little messy. So other questions?